Today we're starting our unit on plate tectonics. A lot of you probably have a pretty good understanding of what plate tectonics is. So what we're going to do is we're just going to kind of go through what the theory is, but we're going to start with the history of the theory, so where the theory began. And it starts with this guy, a German meteorologist named Alfred Wegener. Wegener was one of a breed of explorer scientists who mixed research and adventure, and he did nothing by halves. He was fascinated by meteorology and studied the upper atmosphere's weather from the gondola of a balloon. In 1906, he and his brother Kurt made a balloon flight that lasted 52 hours, which was a world record at that time. He spent several strenuous winters in Greenland making weather observations, and in 1913 he crossed its ice cap with only one companion, using sledges hauled by ponies. But he was obsessed with a single great idea, which he developed as a young man while recuperating from a neck wound he received in the First World War. As Wegener tells it, the idea first occurred to him when he noticed that the coastlines of South America and Africa, were they to slide together, would fit as neatly as two pieces of a puzzle. To explain the coincidence, he proposed that the two continents might once have been one, and then they split apart. Eventually he saw them as parts of a single giant supercontinent he called Pangaea, Pan meaning all and Gaia meaning Earth. Pangaea began breaking up in the age of the dinosaurs some 200 million years ago. Like pieces of a cracked ice floe, he said, they're still drifting apart to this day. So you see, the coastlines here look like they fit together. Some of you probably noticed the same thing. And Wegener was not the first one to notice this, but he was the first one to really research it in exhaustive detail. There was somebody you might have heard of, Sir Francis Bacon. He thought he saw the same thing many years before. In 1666, a French monk named Francois Placé thought the continents were together, and then the great deluge of Noah's Ark broke them apart. But like I said, Wegener was the first one to really investigate in exhaustive detail this idea that he's going to call continental drift. Wegener knew, though, he couldn't just come up with this hypothesis that the continents were together and then they drifted apart without having evidence. So what he did was he collected evidence in many parts of the world. Now, he did most of his research, like I said, in Greenland, and he did a lot of research in libraries and had graduate student type people find a lot of this information for him. So when I say he found this stuff, it wasn't actually him going out and finding it, but he's the one that put all of these pieces together. So he collected 5 pieces of evidence for his continental drift hypothesis. The first piece of evidence we just said is that the pieces, or the continents, looked like they fit together like pieces of a puzzle. His next piece of evidence was fossil evidence. What he found was fossils that lined up across the continents. So, for example, he found this guy, a big, huge lizard called Cynonathus. It was this reptile that lived, you can find the fossils here in South America, and then across the ocean here in Africa. There is no way that this big reptile could have swam all the way across the Atlantic Ocean. The continents must have been together, and then as they drifted apart, the fossils remained some on each. Same thing for this guy, another reptile, Listosaurus, found in Africa, Madagascar, India, and Antarctica. Okay? He must have been on all 3 when they were together, and then they drifted apart because he could not have swam across the ocean, nor could he have lived in Antarctica underneath all the ice. Another guy, Mesosaurus, his big evidence was this tropical fern called Glossopteris. And it was his big evidence because he found it on all 5 of the southern land masses. We're going to be talking about these 5 southern land masses over and over. South America, Africa, India, Antarctica, and Australia. So he found this fossil on all 5 of these southern land masses. And again, you can see that the fossil is basically lined up across the oceans. Also, this tropical fern fossil didn't make sense in some places. In Australia, yeah, maybe. In India, okay. Madagascar, yeah, maybe so. South America, sure. But a tropical fern in Antarctica? That doesn't make any sense. It's covered in ice. It's too cold. You don't have tropical ferns there. Okay? Antarctica must have been closer to the equator and then drifted farther south. So really the fossil evidence is kind of his key piece of evidence these animals could not have crossed the oceans, and he found fossils of animals and plants in places where climatically they shouldn't exist. But he needed more evidence, okay? Just 2 pieces wasn't enough. His next piece of evidence were mountain ranges. And let me find where my picture of mountain ranges are. Okay, over here. So this is showing the mountain ranges. He found things like the mountain ranges on the coast here. The Appalachians match with the Atlas Mountains in Africa. There's a plateau in Brazil that also corresponds nicely in Africa. Okay? And again, it doesn't make sense for these mountains to line up across the oceans unless if the continents used to have been together. Another piece of evidence, or here's more on the mountain belts. You see the Appalachians also extend up into Greenland and then across the ocean into Nova Scotia too. So again, they all kind of line up. Another thing with the mountains that he found, and I'm going to exaggerate this greatly just so you get the idea, but he said, think about how mountains look. They start in the foothills and they kind of work their way up. Okay? That's what he found on one continent, but he found more of kind of a cliff on the edge than the water. And on the next continent he found kind of a cliff with some mountains here, and then water here, and on the next continent he found this. And he said, well, think about it. The mountain ranges must have been together in the past, and it would have formed one nice continuous mountain range. Okay? And again, I exaggerated it. It doesn't look this clear. But again, you put it together and it makes sense. Another thing that he found were glacial striations. Glacial striations are scratches left in the bedrock when glaciers move across them. Okay, glaciers are ice, obviously, but they have rocks stuck in the bottom of them. Okay, so ice with rocks in the bottom. As these glaciers move, those rocks that are stuck in the bottom make long scratches in the bedrock. And you can look at these long scratches and see where the glaciers were. You can also see which way they went because they'll leave moraines where they end, basically kind of mounds of rock. So we can tell which way the glaciers went. And he found the glaciers moving on to South America like this, on to India, spreading kind of from Africa and Antarctica, moving on to Australia. And Wegener knew a lot about glaciers because he spent most of his time in Greenland. And he said that glaciers start on land. Glaciers cannot start in the ocean and then move on to land. It's the opposite. Glaciers, are on land, then they slide off the land and they calve into icebergs. Okay, there's no way that a glacier can form on the water and then move on to South America. It's impossible. Okay, there had to have been land to the east of South America that the glaciers could have moved off of and onto South America. Same thing for Australia. There had to have been land here for the glaciers to move onto Australia from. The last piece of evidence that he found was that the rock sequences matched on the 5 southern land masses. Rock sequence, just basic idea. Basically, if you dig a hole, what he found was basalt on the top, underneath basalt was sandstone, underneath sandstone was shale, underneath shale was coal, and underneath coal was glacial till. He found this same sequence, again, on all 5 of those southern land masses. They weren't the same thicknesses, they didn't look exactly the same, but he found this same general sequence on all 5 of the southern land masses, which again means that they must have been all together forming the same rocks. And you find things like coal in Antarctica. Coal forms from swamps where tropical plants are dying. Okay? How could there be tropical plants in Antarctica? Well, Antarctica used to be farther to the north, closer to the equator. How could you find glacial till in Africa? Well, Africa used to be farther south, near the poles. Okay, so the climatic evidence fits. So he has all these 5 pieces of evidence. He puts it together. He writes a book called The Origins of Continents and Oceans in 1915. And one of the central quotes of his book: "It is just as if we were to refit the torn pieces of a newspaper by matching their edges, and then check whether the lines of print run smoothly across. If they do, there is nothing left but to conclude that the pieces were in fact joined in this way. Okay? If you rip a piece of paper, the lines of print run smoothly across, you can read it, they must have used to been together. So he came up with this hypothesis, and here it is. Approximately 200 million years ago, all the land masses were together as part of a single giant supercontinent called Pangaea. Notice that there are 3 A's in Pangaea. They then drifted apart because of the gravitational pull of the moon. Okay, so gravitational pull of the moon. Okay, so he thought the moon causes the tides because it pulls the water. The moon also can move the continents. Okay, so the gravity of the continents, or the gravity of the moon, can move the continents. Here's again another picture, and I like this little drawing here. Watch, so here's Pangaea. Watch as it splits up. They're putting the evidence on there, the different fossils and everything. But watch as it splits up. Bam. Okay? It doesn't just split like a shotgun hits it and all go in all directions. The northern section breaks off first from the southern section, and then it breaks apart. Okay? So you can watch it one more time here. Northern section, then southern section splits. So Pangaea is the whole one. The top part after it breaks off is called Laurasia, Greater Asia. The southern land masses together are Gondwanaland. And make sure you list the 5 southern land masses of Gondwanaland: South America, Africa, Antarctica, Australia, and India. So what was the scientific reaction to his hypothesis? It was not good. Not good at all. Here's one quote. In his book, he is not seeking truth. He is advocating a cause. He has suggested much. He has proved nothing. Another person. If we are to believe Wegener's hypothesis, we must forget everything which has been learned in the last 70 years and start over again. They really hated his idea. Okay? They didn't like it for 4 main reasons. First reason was he was a German. Okay, simply because of his nationality. Germans had just lost World War I, and people didn't see Germans as knowing anything. He was a meteorologist. Okay, he studied the weather. And here he was telling geologists that they were wrong. They didn't like that. That's kind of this last quote. Okay, if Wegener was right, then they were wrong. And they didn't want to be wrong because all their grant money and all the money they got was gone to waste. They wouldn't have jobs. They didn't want him to be right. The last reason was they didn't like his mechanism. Wegener's mechanism was the moon's gravity pulled the continents. They thought that was ridiculous. Okay? So you think about these 4 arguments. Are any of them good reasons for not believing Wegener? Yeah, the last one. The mechanism. The moon is not strong enough to believe him. Okay, so I might end there. Wegener dies. He goes back to Greenland, thoroughly disgraced. He dies of a heart attack on the Greenland ice cap with basically nobody believing him, especially in the northern hemisphere. A few people in the southern hemisphere believed him, but really hardly anyone believed him. He leaves with one prediction. He says, when we find out what the ocean floor looks like, we're going to change our beliefs. So tomorrow what we need to do is figure out, well, what does the ocean floor look like? Is it going to prove Wegener correct? Or is it going to further prove him wrong?